We have seen that decimals can be terminating and can be repeating, but there are decimals that are neither. One example of such a decimal is the number pi. It's called pi, the Greek letter pi, pi. You may recall that pi is approximately 3.14, so 3 and 14 hundredths, but that is not an exact value. The decimal for pi actually continues on forever to the right, and it does not have a repeating pattern. That is, there is no set of digits that repeat over and over again. So if you want to see the first 1,000 digits of pi, well, here you go. You can now cross that off your bucket list. There are technically many more of these types of decimals than there are terminating or repeating. And most do not have special names such as pi. Here is a decimal that does not have a repeating pattern. Well, that does have sort of have a pattern, but it's not a repeating pattern. There is no set of digits that you could put over the over bar to say that they repeat over and over again. So I'll start with 0.1, then 0.1, 0.1, 0.01, 0.001, 0.001, and so on. A decimal that is non-terminating and non-repeating is called an irrational number. That is a technical term indicating that these sorts of numbers cannot be written as ratios. So ratio is another word for fraction. It says nothing about how crazy they are. So let's try to range these from least to greatest. So 0.375 with the 75 repeating. As a decimal, that's 0.3757575, and so on. The second one is 0.375, and then the 5's repeating. And his third one is 0.375. All right, so in terms of the first three digits, and then the last one after that is just all zeros. If you look at the first three digits, they're all the same. So the next digit, the 10,000th place, this is what separates the three numbers. The smallest of those is going to be 3/8. And then the next smallest is the 5 there, so the 0.375 with the bar over the 5. And then the largest is the 0.375 with the bar over the 7.5. So from least to greatest, 3/8 is the smallest, 0.375 with the bar over the 5 is next, and 0.3 with the 7.5 with the bars over the 7.5 is the largest. A little bit more complicated. This one on the left, if I take it out, 0.45838383. This one is 0.4583, and then 4583, and so on. And the last one, I'm just going to put in the calculator. So if I go 11 over 24, I get 0.4583, and then after that is just all threes. Okay. So if I look at the first four digits, 4583, 4583, 4583, they're the same. The 100,000th place is where they're different. And once again, the fraction is the smallest of the bunch. And it looks like the next smallest would be the one that's in the middle. So the 0.4583 bar over the entire, all four of them. And the 0.45 with the 83 repeating is the largest. All right, in each case, decide whether which number is smaller or if they're equal. So we saw in an earlier video that 1/3 is really 0.3333 repeating, whereas 0.3330. So if you look at that fourth place, this is 0. The fourth place here is 3. That means that 1/3 is the larger number. So the first number is smaller. So in each case, decide which number is smaller. So this first number is the smaller number. 1/3 is the larger. For the second one, 9.99999 repeating or 10. Well, if I go to the trick I did earlier, if I set x equal to 9.999 repeating, that's a period of 1. So if I multiply by 10, this would be 99.9999 repeating. So this would become 9x equal to 99 minus 9 is 90, and everything after that disappears. Divide by 9, you get x equals 10. And what that tells me is that these two are actually equal.